Example 14 says a sine wave oscillates between 6 and 10, has a period of 4 pi, and is shifted left pi. Write an equation of the wave in the form of y equals a sine bx plus c plus d. So they want you to give the final answer with the capital B distributed out. So let's show you how to do this. So the word oscillate, right? Some of you have had physics, you kind of know that that's what that means, but oscillate just means bounce because sine waves bounce between their minimum and their maximum value. So if it's bouncing between 6 and 10, it's telling you that the minimum of the wave is 6 and the maximum value of the wave is 10. The time period is 4 pi, so that's how long it takes for one wavelength to travel. And we're shifting the wave left pi. So that means that is going to be the phase shift. So if I start with my general form of my wave, I like to be able to see all 4 of these quantities. Oops, forgot the sign. Let's try again. There we go. A sine capital B x minus c plus d. So A, I can calculate directly using my formula. A is max minus min divided by 2. So that's 4 over 2, or 2. So that's the amplitude of my wave. So I'm going to come back here and go ahead and put a 2 in. The frequency of my wave, B, is 2 pi over the time period. And the time period was 4 pi. So my pi's cancel. 2 over 4 is 1/2. So I have a frequency of 1/2. The wave was shifted left pi. So that means, right, it looks opposite as what it should. So it's x plus pi. To get d, I can average the max and min together. So d plus 6, or 10 plus 6 over 2, is 16 divided by 2, or 8. So this wave was shifted up 8 places. So now, to give my final answer in the form they want, I need to distribute the 1/2 across. So y equals 2 sine 1/2 x plus pi over 2 plus 8. So you can see very clearly here that the phase shift was pi, but in the final wave, right, when we write it like this is not showing you the phase shift. Now, if I factored out the 1/2, this would show up as pi, and you can see that very clearly in the original incarnation of the wave. Part B says, well, now sketch the wave you found in Part A on the interval from -2 pi to pi. Clearly label the amplitude, period, y-intercept, and scale the x-axis in increments of pi over 2. So a lot of times when we draw waves, people get in a lot of trouble because they don't know how to draw the x scale. So we were actually told here, use pi over 2 as our tick marks. So I'm going to do that first. So I'm going to say, well, I'm going to have pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So the wave is going between 6, so I'm just going to draw a line at 6, so that's the bottom of my wave. The top of my wave is at 10, and then I saw that my D, the middle of my wave, is at 8. So these 3 lines are just going to kind of help me make sure I stay in my lane when I'm graphing this. So a sine wave starts at its midpoint and goes up. So the normal sine wave would start right here at 0, 0, right? But my wave shifted up 8 places. So my midpoint of my wave is here. And then I was told we shifted left pi. So if I shift over and I put my point at 0 pi, or negative pi 0. So I went left pi. And then the time period of my wave was 4 pi. So if you look at wave-like motion when you're graphing, there's a really easy way to do this. Well, the other thing about a sine wave is however long it takes the wave to go from its midpoint to its max, and you can see on this wave it was pi over 2, it's exactly the same amount of time it takes for it to go back down to the midpoint. So that's another pi over 2. Then it's another pi over 2, right? Another pi over 2, another pi over 2, another pi over 2, and so on. So each one of these, you can break a wave into 4 parts. 1, 2, 3, 4, right? And we graph this by doing the 4 quadrants. So it takes t over 4 is going to be 1/4 of the wave every pi. So that means if this is negative pi, instead of at pi over 2 going up, right, I have to go all the way to pi to get to my max. Then if I count another pi, I'm back at the midpoint. And then if I count another pi, I'm down at the bottom. And I can follow the same pattern over here. The wave's coming down, so I have to go over pi to get to the bottom of the wave. So if we look at this, one complete wavelength of my wave took 4 pi to go across, and that's exactly what the time period said it would be. The distance from negative 2 pi to 2 pi is in fact 4 pi. So this wave is very slowly crawling by. It's going at half the speed that it normally would. And if you look at our frequency, it said it was going half the speed it should be going. So it's coming around half as often as a normal sine wave.